Hello everyone, welcome back to my channel Tech Explained Simplified by Arujit. My name is Arujit Datta and this is my first video, so we're going to start with SD-WAN first. So let's start. So what is SD-WAN? SD-WAN is a technology that uses software defined networking, or what is called as SDN concept, to distribute the network traffic across a wide area of network or WAN. And enterprise and organizations have adopted the SD-WAN as a cost-effective way to connect branches offices to their own data center and to cloud-based applications. So what SD-WAN does basically, it automates, it centralizes, and is more flexible rather than MPLS or traditional WAN technology. So which creates a more agile WAN environment for the enterprise, mid-size, and large businesses. So in SD-WAN, it's a approach that managing the wide area network that decouples the network control plane and the data forwarding plane, enabling centralized management and automation of the connectivity. So, what is the meaning of decoupling of network control plane and the data plane? So, normally in a router and all our network devices, so we have that network plane and data plane which is involved. So, what SD-WAN does, it separates both them. So it centralizes the control plane in a separate place, and the data plane is been sent it over to the actual hardware devices like the local data centers and all. So what is the work of control plane and data plane? So what control plane does, so it's basically work like a brain. So it's responsible for the decision making, so where the traffic should flow. Okay. And how data plane works? Data planes is the responsible for that action what brains is telling. So it moves the packets based on the decisions that control plane has taken. So the reason why companies are moving to SD-WAN now, because it's easy to handle. There are a concept like zero touch installation and everything, so that is very easy to handle rather than going one by one router to configure all the things. So it can be automated configuration, so all the customers, all the end routers that is present, the centralized action can be taken. It's more flexible and cost effective comparative to traditional WAN and MPLS. So now let's see how SD-WAN works. So SD-WAN basically creates an overlay on top of the physical network. SD-WAN architecture creates a virtual overlay that abstracts the underlying private or public WAN connections like MPLS and broadband and fibers. So this overlay enables enterprise to keep their existing WAN connectivity, while the SD-WAN centralizes the network control and enables real-time application traffic management over the links. So how the SD-WAN controls is and how they manage it. So basically the central controller manages the SD-WAN, and the controller is typically a software client which directs the data flow between one point to the another point, and it distributes the network and security policies to all the connected devices. So any person who is managing that SD-WAN, so they can basically with the central configuration, centralized system, they can basically configure same type of configuration to all the network edge devices. So which is the concept of zero trust provisioning, and it also minimizes the need of engineers to manually configure routers in each branch location. Okay. So now what it does, providers typically, normally the SD-WAN providers, they typically provide two type of SD-WAN model. One is the overlay SD-WAN and another is managed as a service. So managed SD-WAN. So in overlay SD-WAN, vendor provides the customer with a network edge device that contains that software necessary to run that SD-WAN technology. So the customer, they need to uh, configure it, or they need to run that SD-WAN technology on their devices, and then it will work further on the overlay links. Whereas in the managed section, in the managed SD-WAN, so in the managed SD-WAN, customers don't need to configure it separately. It will be, and customer don't need to own and manage their edge devices as well. It will be done by the provider itself. However, in both the cases, the main concept and the main capabilities are same. So it's like virtualization, centralized policy, and dynamic traffic management. So these three will be same for both the services. Either it's overlay SD-WAN or it's a managed SD-WAN. Okay, now we can see it's a basic diagram of SD-WAN architecture where we have the branches here and the SD-WAN overlays is here. So if it's a overlay SD-WAN service, then the customer needs to configure the software SD-WAN enable software in the branches sections here, and then it will start working. And if it's a managed SD-WAN service, then customers doesn't need to do all these things. It will be automatically done by the provider itself. So this is a basic architecture we have here. So now we will see the difference between SD-WAN and traditional WAN. So in traditional WAN, it's a geographically distributed network. It's connectivity, it connects all the multiple LANs and in a geographically distributed network. So it has the capability of load balancing, optimization, disaster recovery, VPNs to enable connectivity and provide security as well. However, these things are time consuming, and if we have a large network, so it will take very much amount of time to configure all the things to complete in a global network. So what SD-WAN does, the SD-WAN architecture, it relies on the virtual overlays basically. So it will help the team to change and replicate policies and configurations among the distributed SD-WANs all at a time. So for example, if any company wants to change any configuration to their multiple locations together, it can be done by using SD-WAN. Okay, so in SD-WAN, along with the SD-WAN, what it will do, it will use the same existing WAN connections and the devices, but it will be remotely managed by the SD-WAN provider or who is supporting the SD-WAN section, and due to which it can be easily managed by their centralized controller, and it also enables a real-time automated and standardization configuration change as well. So this reduces the opportunity of human error and saves lots of time and cost as well. So it's a basic difference between SD-WAN and traditional WAN. So here we can see the difference of between SD-WAN and traditional WAN via diagram. At the left hand side we can see the traditional WAN connectivity. So where we have two devices and the normal WAN connectivity is between them. In SD-WAN, how it is doing, it's not replacing the existing connectivity, it's using the same existing connectivity, but along with that it's configuring a new SD-WAN software which is basically centralizing the rest of the task and doing it easily. So this is a basic diagram which shows the difference between traditional WAN and SD-WAN. Okay, so now we'll see the difference between SD-WAN and MPLS. So MPLS has been a trusted connectivity options for decades. It's providing guaranteed network performance with cost policies that validates throughput, delay and jitters as well. So it has the advantage of being a private connections, and MPLS providers can deliver a more comprehensive service level agreement that normally other than the providers that offers only a connectivity over the public links. However, so MPLS is also a bit expensive and it's somewhat inflexible as well. It often takes more time to provision MPLS connections and put it in a operation mode compared to SD-WAN. So what many organizations are doing, so they are adopting a hybrid strategy using SD-WAN for general and business internet traffic while retaining a MPLS for critical workloads. So that is also an option that currently organizations are working on. So here we can see the difference between SD-WAN and MPLS in a structured manner. So in design type, normally in SD-WAN virtual overlays is connectivity, however in MPLS is a fixed. Cost is lower in SD-WAN and higher in the MPLS section. Performance is application based routing and dynamic path selection is present in SD-WAN. In MPLS it's a consistent and the low latency via SLA. It can be changed, but there's again an extra configuration and is needed. Then security is inbuilt encryption is there in SD-WAN. For MPLS is a private and need the extra encryption layer. Then we have scalability and management. So management also is one of the important things. So in SD-WAN is the centralized and user-friendly interface we have, but in MPLS it's a very complex and specifies expertise only can configure it properly. So otherwise there is a chance of erroring. And cost and reliability, so we have underlying internet can be used for multiple circuits for failover in SD-WAN, but in MPLS we have the dedicated line with strong cost policies configured. So for the cloud support as well, SD-WAN is much easier and it's for excellent for cloud and remote apps, whereas MPLS is very difficult for the cloud support. So these are the basic difference that we have between MPLS and SD-WAN. So in few words, if we want to see the advantages of SD-WAN, first is lower cost, then is very flexible, deployment is very easy, then it's a centralized management and having the visibility all over it into its application performance, already having a built-in encryption and cloud based also easy. But in the MPLS, the most of the disadvantage things are it is comparatively very expensive and it's not very easy to configure it in a single time in short time. It's time taking things. Its management also comparatively slow and complex. Provisioning takes lots of time. Then for cloud access is comparatively weak, and it latency got also increased if they are going through backhauling, then it increases the latency as well. So this is the overall difference that we can see between SD-WAN and MPLS. So now we will see the difference between VPN and SD-WAN. So these two technologies having their own similarities and difference as well. So like VPN technology, SD-WAN also securely connects remote sites to the data center resources, but SD-WAN enhanced this method by applying intelligent traffic routing and security policies, while VPN typically work well for businesses with a single IP backbone. That architecture isn't reliable when introducing voice and video or when congestion impede into the network. So compare SD-WAN technology and VPN. In SD-WAN, the granular level of support makes it far more advanced when it comes to cost or quality of service compared with basic internet VPNs. Also, VPN can't always provide the internet connectivity with optimization and advanced security that cloud-based services requires. So here we can see the diagram of SD-WAN and VPN and how the connectivity is work. It's a simple diagram. So now we will see the key benefits of SD-WAN. So first thing is lower the cost. So it's reducing the cost while implementing it, and for the further support as well comparative to traditional WAN or MPLS. Then it's improve the application performance. So it how it does, SD-WAN uses a combination of WAN optimization techniques, and it dynamically shift traffic to accommodate each application's requirement. Then it can automate the failover and redundancy. So it offers redundancy among WAN connections, automatically flailing over to a second part if the primary one fails or it get congested. So this this automated redirection of traffic boosts applications and network performance and also reduce the latency. Then it's reducing the reliance on MPLS. So it how it does it enables the organization to depend less on expensive leased MPLS circuits. It can send low priority data over the cheaper public internet connections and the reserve private links for mission critical or latency sensitive applications traffic such as voice over IP. Then it automates the site deployments, configuration and operation. So it It uses various capabilities to enable automated processes such as centralized controllers or machine learning, and it increases the traffic visibility by end-to-end. It enables the end-to-end visibility across the network, including the LAN, WAN, and the cloud environment. So this helps network administrators access and troubleshoot network issues more quickly. It also provides an extra layer of security within the SD-WAN system. So these are the key benefits of SD-WAN. So here are the few challenges of SD-WAN, which are the most common SD-WAN challenges. So the first one is vendor selection. So it can be confusing to identify the correct vendor and analyze the options and documents for business requirement. Then the underlying provisioning, which is the second one. So when choosing SD-WAN architecture and procuring connectivity, so need to pay attention in the network performance support and the IP backbone connectivity. Then the third one is cloud connectivity. So most of the enterprise require a cloud access to public cloud environment. So evaluation of each vendor strategy for providing this access is needed and is a must. Then the cost reduction. So cost savings with SD-WAN don't always show as quantifiable figure on the budget. However, it shows in the overall business profit. And the last one is management. So vendor and service providers offer co-manage and fully managed SD-WAN options, and to choose that model, and whichever is model is for beneficiary for them, they need to choose that. So these are the common challenges for SD-WAN. So to conclude our SD-WAN introduction, so the first thing what we have learned is the transformation of WAN. So SD-WAN represents a shift from a static or WAN to a dynamic software-driven architecture. So it brings agility, intelligence, simplicity to the WAN part, enabling enterprise to connect branches and data centers and cloud more efficiently. Then the second thing is decoupling of control and data plane. So by separating the control plane, which is the brain, or which works like a brain, and the data plane, which actually works, so it enables the centralized policy management and distributed information, leading to a faster deployment and easier troubleshooting. Then the third point is cost efficiency and performance optimization. So traditional MPLS networks are expensive, and SD-WAN help us a lot on that. Also, it reducing cost while maintaining the maintaining or while using the same connectivity. Above that, we are just using a software, and it's also increase the performance using dynamic path selections and real-time link metrics. Then the fourth is security and cloud integration. So modern SD-WAN solution integrates with the cloud security and the next generation firewalls, ensures encrypted policy-driven access to SaaS, IaaS, and the remote users. And the last is operational simplicity through centralization. So centralized management like Cisco vManage or FortiManager or Palo Alto Prisma SD-WAN allows unified visibility, policy automation, and analytic, reducing human error and simplifying the operation. So this is the overall conclusion that we can get from this introduction chapter. So that's all on the introduction of the SD-WAN. I hope you guys like it. Thanks for watching, and subscribe my channel for upcoming videos. You guys also share me a feedback if you like it, what you don't like it, and so that I can fix these things up in the next videos. Also, I'll be coming upcoming videos with more details of SD-WAN and how the things work on there. So stay tuned. Thank you all.